All right, and then we'll discuss the delete. Okay, in your doubly linked list, we are going to discuss one insertion which is left. Okay, and then we are going to discuss the delete functions. Okay, in that particular same doubly linked list only. All right. Now, see, before moving forward with doubly linked list, I want you guys to remember or just recall what is doubly linked list. Anyone? What is doubly linked list? Or just tell me that how will you identify that this kind of a structure given in front of you is a doubly linked list. Suppose a linked representation structure is given to you, okay, a diagram. Then how you are going to make out that this is your doubly linked list?
If we can go back and forth.
Okay, one condition, you can go back. You can go back from each node or from just from last to first.
No, from each node, because we
Correct.
have we have double link, so we can update it. We can move it.
Exactly, correct. You can move backwards. You can go back to any node. Okay, in your doubly linked list. Unlike your circular linked list, what happens in your circular linked list? In your circular linked list, you can go back. Okay, you can go back to the first node, but that
But
is from
we
last
cannot
to
go
first.
from between.
Exactly.
We have to traverse from one end to another.
Correct. Absolutely right. You have to, in a circular linked list, what these things were happening. It was going back, but you had to go to the last and then you come back. Okay. It is like you are standing in the queue. All right, you are standing in a queue for let's say your favorite food. Okay, your favorite food is distributed free of cost, but there is quite a bit of line. All right, so first it was singly linked list. Okay, so there you were coming line by line. All right, the connection between all of you was with let's say like small kids, okay, holding hands like that. Then we came up with a solution that okay, there are some privileged children in the queue, so they can be given the free food. All right, so you can just go from the last one can go back to the first one, like that you can imagine. All right, but the middle ones cannot move. The middle ones should be there. If you want to go to last to first, you have to traverse through those middle ones. All right, then we came up with a solution that no, this is injustice to the middle one. If I want to go to the third node or fourth node, I don't want to go back from first to and then third. So the programmers, the designers introduced your doubly linked list. In doubly linked list, there are two links. Okay, so you can move forward and backward from any node, from any given node. All right. So that was your doubly linked list, okay? But there is one condition in doubly linked list which is not, which is different from your circular. Exactly, absolutely right. In your doubly linked list, you need to remember that the first node previous part is null, last node next part is null. Okay, so whenever, see, I got some queries from the students that they are having some problem with linked list. They are getting what I am explaining in the class. They are getting, okay, but when they sit for self study for linked list, okay, then they are facing some issues. So the easiest way is what? I will upload this PPT today. See, there is insertion operations for DLL is given here. Okay, I'll remove this one. This is a bit messy. Here is the good one which we had discussed. So I'm going to keep this. There is a circular linked list. Okay, whatever we have done with circular linked list, it is there. DLL is there. Okay, whatever we are going to see further in DLL, we are going to do it here only. So it will be easier for you to understand your DLLs. Okay, then this SLL insertion which was discussed in your respective labs. Okay, that is also there in this. All right. And in one of the lab I have started stack. Okay, so that is also going to be there here. All right, so this whole Excel file I will upload in your e-content. Fine. Now what you have to do when you sit with your linked list chapter or say linked list topic, okay, suppose you are doing DLL, okay, then open up this Excel. Fine. Keep it in one split screen in one side of your screen. In another side, keep open your PPT. Okay. Let's suppose, or you can just go in a way that I am teaching you. That one side there is an algorithm. On another side, I am showing you how that algorithm is working. All right. At that moment, when you are doing like this, okay, the algorithm is on one split screen. The diagram, this color-based diagram is on another split screen. Okay, it will be helpful for you to remember. Okay, you guys do understand. You guys understand all the concepts very clearly when I'm explaining it to you. Okay, even I do agree with that, and I have seen your performances in your assessment tests also. Okay, so that is fine, but the problem is what you are facing difficulty to remember the concept. Okay, and that is happening when you are coming for the practical sessions. Okay, you do know how you have to approach, but in the practical session things are not working. Why? Because you are not visualizing something like this. When I say it is a doubly linked list, you should just come and visualize this diagram, that there will be one null value in the first node previous, there will be a null value in the last node next, and all the rest of the values will have forward and backward direction arrows linked with each other. All right, so this diagram should come into your mind when we are talking about any kind of linked list. If I say circular linked list, then directly this diagram should be in your mind. All right, that in circular linked list I can go from last to first. Okay, and all the nodes are connected with a single link. All right, this diagram should come into your mind. Fine. So if diagram is very much clear, imprinted in your minds, okay, then you can solve any case, any given case, okay, for if whether it is insertion, whether it is deletion, anything. Fine. So you try to understand, or say when you are going for your sitting with your self study with your linked list, okay, again after the sessions, then try to do this method. All right, in one split screen, keep this diagram in front of you. In another screen, keep the algorithm. Okay, if you're not comfortable with this Excel, then you draw yourself. Take a pen and paper or a book, okay, and draw yourself. When you do this, okay, this drawing things, when you do draw things, you'll remember them easily rather than your theories. Okay, so that is one advice from me to all of you. Fine. Okay. See, today we are going to insert the node, the remaining case number 5 in your doubly linked list. Okay. And what I have planned today is we shall study your linked list, okay, till around 11. All right. From 11 to 11:30, we'll have a small revision exercise. Okay, I have prepared one spinning wheel. If you can see on your screens. Okay, this is a spinning wheel. All right, with all the given inputs, and there are some topics enlisted here. Okay, for example, circle. They're all related to a linked list. Okay, and this purpose of creating this wheel is what? So that you can revise. Okay, you don't get confused. In class only you can answer me, no matter it is right or wrong. Okay, just try to answer. Fine. If it is wrong, then also it is your gain. If it is right, then also it's your gain. Okay, if it is right, you will build up your confidence. If it is wrong, then just correct it, take it in a way that, okay, fine, what I was thinking was a bit out of the way, this is the way to think and this is the right answer. So then also it is your gain. Okay, so we are going to do this activity, at 11 or 11:05. Fine. And this is a revision activity, okay? I have singly linked list here, circular linked list here, some conditions for queues and stacks, okay? Doubly linked list, some properties, alright? So all these small topics I have kept. So it won't take much of our time also, alright? We'll do that at the end. Okay. See, you can do it something like this. Alright. What we are going to do today, we are going to see one insert case in a sorted linked list. Okay. Now see, in your practical also, when we were doing a practical for singly linked list, we have done a practical where sorted insertion we were going for, right? So what is the constraint here? Your doubly linked list should be existing in a sorted manner. Let's check, is it in sorted manner? 100, 200, 210, 240, 300 and 140. Okay, we can make this as 340 now. Okay, so this is my sorted linked list. Alright. Now what I have to do here, I have to insert a node in such a manner that after the insertion, after I insert that particular node, this doubly linked list should be in my sorted order. Okay. Alright. Clear what is the aim? Yes or no? Students, yes or no? Did you got what is our aim for insertion? What should happen after I insert? Okay. See. Now what does my algorithm say? First three steps. Create the node. Okay. Alright. The first three steps are for creating the node. So let's go and create a node first. Okay. Okay, so this is my new node and memory allocated to my new node is what? 150. Alright. Now, what is the next part in my algorithm? Step number 4. Set new node data equal to val. Okay. Set your new node data equal to val. Alright, so I have to give some data part. Tell me some data value which I should give.
$290.
Okay, 290. Alright, so 290 is my data part for the new node. Okay, so new node data equal to your whatever you have scanned. Okay, from your printf scanf statements, whatever you have scanned, that will be stored in my data part. Alright, so 290 done. Now, what I have to do? I have to take pointers. Why I am taking pointers? So that I can traverse in my doubly linked list in my DLL. Okay, and I will reach my target area. See, I'm saying target area, okay, not target node. Now, just tell me logically that if 290 is my node value, okay, this is my new node which is to be entered, alright, then where ideally it should get placed? In my this existing doubly linked list, where ideally it should get placed? See, the diagram is in front.
After 240.
Between
Exactly.
240 and
After
300.
240. Exactly. So this is the area. Okay, I can say this is my target area. Okay, it should be between node having memory address 3010 and between 1015. All right. See, again I'm saying here that in your linked list, okay, any linked list, this memory can be assigned anywhere. It is not that it will be assigned in serial order like your arrays. Okay, so don't have that thing in your mind that it is 150 here, so it should be here somewhere. No, this new node 150 is what? 150 is the memory address, the full block allocated by your malloc. Okay. Fine. So this is 240 and this is 300. In between, this 290 should get placed. Okay, that is my aim. All right. So first of all, let's just go and make this thing a little bit more systematic. All right. Forward link for this one. And backward link for this. Okay. Now between 240 and 300, I should place this 290. So let me just write it here now. And what we are doing in given in a sorted linked list. Okay. We have to insert a node in the sorted linked list. So I will increase some lines here. Okay. Insert node in sorted DLL, doubly linked list. Alright. Now see, let's go and see the algorithm next. We have to take PTR and pre-PTR. Alright, as we are taking so far. Okay, so PTR equal to start, pre-PTR equal to PTR. So go to your head, okay, and assign what? PTR equal to head, all right, and pre-PTR
Equal to PTR.
exactly equal to your PTR, all right. So easy so far. This should be there in your mind, because every time when we are doing insertion, before, after, or in between, we are taking 2 pointers, all right. So PTR equal to head and pre-PTR equal to PTR. So both pre-PTR and PTR are right now pointing to this particular node. Okay. So your pre-PTR can access the data part, the next part, and the previous part. Your PTR can access the data part, next part, and the previous part. All right. Now what we have to do? Now go for the traversal. Now in traversal, again we have to check. What we have to check, because this is an insertion. This is insertion with respect to what? Your sorted linked list. Okay. So you are going to compare your each node data with the value you have provided in your new node. Okay. So what you are going to write here? PTR of data, okay, is less than your val. Okay, so less than equal to val. What is this val? New node data. So you can also write something like this also. Okay, new node data. Alright, PTR data less than new node data. If that is the case, then what I have to do? I have to move my pointers. How my pointers are going to move? Pre-PTR will get the position of PTR. Okay, PTR will move to the next node. So here I am going to write pre-PTR is equal to your PTR. Okay, and what about PTR? PTR shall move to the next node with the help of PTR next. All right. Now see, let's see this while loop first. PTR of data. Where is PTR? PTR is at 1000. So what is the 1000 data part? 100. 100 less than 290? Yes. So what I need to do? Pre-PTR remains as it is here. Okay. Your pre-PTR remains here only as it is. It is not moving in the first iteration. Okay, just your PTR shall move. So this PTR from 1000, it moved to PTR of next. What is PTR of next? 1010. All right. So it moved there. Fine. Now again check with respect to this PTR of data. Okay, because that is the condition here. All right. 200 PTR is less than 290. Yes. Okay, so what I need to do now? Move my pre-PTR. Where is my pre-PTR? Here. Where it should move? To the position of my PTR. Okay, so PTR moved forward. Alright, so from here, here is your PTR, pre-PTR. Okay, and what should I do with PTR now? Next line of execution. It should move to the next node. So PTR moves here to 2012. Okay, node at 2012. So PTR is here. Again check 210 less than 290. Yes, what I should do? Move my pre-PTR to the position of my PTR. Okay, and about PTR I need to move forward. So my PTR moves here. Again check 240 less than 290. Yes. So what I need to do? Move my pre-PTR. Okay, so pre-PTR is here. What I do with PTR? Move to the next node. So it is here. Alright, now see 300 less than 290. No, so stop your while loop here. Okay, your while loop will stop here only. Now see, we reached our target area, right? We know that it is going, this 290 has to be between these two nodes. So we reached our target area. Now what we have to do? Now see, now first of all, you go and update these two values, the values for your new node. Okay, so then what you are going to do once you reach, you come out of your while loop, then write new node of first this part previous. Okay, so new node of previous is equal to what? Your pre-PTR. Okay, because that is the node which is going to be, you know, the backward link for this one, for this part. Okay, so this previous part, when I execute this new node previous equal to pre-PTR, it is what it is going to store here, 1015. Fine. So this previous link, this previous orange link just got created. Okay, 1015, one thing created. Now go for this one. I have to create a forward link so that this 290 now points to 3010. So PTR can help me with that. Okay, so here I am going to write new node next. Okay, is equal to PTR. Okay, so what this part is going to store? The value held by a PTR, that is 3010. 3010 placed here. So what I did, I created a forward link, okay, from my new node. So this is what it has done. Obviously now I have to delink these two, right? these two portion, these two highlighted areas are to be delinked now, because they should not point towards each other, but now it should point to the new node. Okay, this 1015 should have a forward link to this new node, and this 3010 should have a backward link to new node. Alright, so we are going to update that. So now what you are going to do with the help of your first pre-PTR of next is equal to what? Your new node. Okay, so what we did, we delinked this part. Okay, we broke this and we linked it to here. Alright, by updating this address from 3010 to 150. Okay, we broke the link here. Fine. Now similarly for your PTR of previous, because we have to create the for a backward link. Alright, so PTR of previous again equal to new node. Alright, so what you did again, when you are updating this 1015 to 150, you broke this link in between. Okay, in between these two nodes, and what you did, you pointed that link to your new node here. Okay, and this marks the exit of your function. Now see, check, head is pointing to the first node. First node is having null value. Okay, all the nodes in between having backward and forward links, yes, and the last node here is having null value. So this is my correct doubly linked list. Insertion is perfect, and all my nodes are in ascending order. Okay, so these are the steps. These are the steps for inserting the node in your sorted linked list. Any doubt here? This is the traversal part. Okay, these 3 lines is your traversal part, and rest of the four are your link creating. Okay, these 4 links are created, so 4 lines of code there. Any doubt, anybody? Yes or no? Okay, I have some queries.
No, man, no doubt.
Explain the traversal part from head. Okay. See, from head, you are taking 2 pointers. Okay. Why always we are taking 2 pointers from head? Because head is the starting point. Okay. The starting point which can help you to go and traverse inside your doubly linked list. It is a starting point because it is holding the first node value. Alright. So your pre-PTR and PTR are at your head. Now in order to traverse, okay, why we are traversing? Because we want to reach this target area. Okay, so that in between these two nodes we can place our third node, or you can say the new node. Okay, so what you are comparing for the case of traversal, you are comparing the data part of all these existing nodes of your doubly linked list with the node which you want to insert. Okay, so if those existing nodes are less than the new node data, okay, then you move forward. How you are going to move forward? By giving the position of your pointers, okay, to one another. So position of PTR assigned to pre-PTR. Okay, what about PTR? PTR should move to the next node using this next link. Okay, so you are going and traversing and reaching your target area. All right, Aditya, now I suppose you are getting it or not? Okay, fine. So this is what your insertion. We are coming to the end of your insertion in your doubly linked list. All right. All the 5 cases are done. Fine. Okay. Now what we are going to see? Now we are going to see the deletion part. Now again in deletion, so far with all the given variants of your linked list, okay, we have seen delete the node from the beginnings, okay, delete the node after, before and end. Okay, so the same cases we are going to see in your doubly linked list. Okay, so let me just do one more sheet here for you. See why I'm doing this, because after all I'm going to share this with you, so it will be easier for you when we are when I am not there to explain and you are doing your self study part. Let me just draw this. I have to adjust some parts here. Okay, this is your uh, existing doubly linked list. Now what we are going to do, we are going to have the delete cases here. Okay, so the very first case, delete from the beginning. Now this is not the first time you are seeing delete from the beginning. All right, so can you tell me from your end, if I want to delete from the beginning, what all changes will incur? If you are going for delete at the beginning, okay, that means the first node is to be deleted. Okay, so what all changes can you just have a hunch? What are changes will occur?
First we have to move the head, and second we have to free that PTR.
Correct. Then we need to move our head from first node to the second node, and we have to free up this PTR. But then, is it satisfying my doubly linked list properties? Once I move my head here, suppose I moved my head here,
Then the previous link of the next node will be null.
previous node of this one will be null.
Yes.
And you are freeing up this particular area of your memory address.
Yes.
Is it? Correct. Absolutely right. Vidhi, was that you?
Yes, ma'am.
Good. Good going. See, let's compare it with algorithm. Okay. First of all, do not forget. Okay. First of all, what is the first step? You have to check that your doubly linked list is existing or not. You want to go for deletion. Okay. Then does your doubly linked list exist or not? If you want to, it is something like this, that you want to have a pastry, but when you go and ask for that pastry is not there. Okay, so what is the first question you go and ask? Do you have this pastry? Okay, if yes, then give me 2 pieces. If no, then don't. Okay, you just move out of that shop. So here you are going to first check, is there a doubly linked list for you to perform the deletion? So if your head is pointing at null, okay, that means there is no doubly linked list, and simply you are going to move out, okay, saying that doubly linked list does not exist. Okay, but if the doubly linked list is existing, okay, this if condition head equal to null is not equal to 0. All right, then take one pointer. Okay, so let's take a pointer here. All right, so what is my pointer going to be? PTR, and I'm taking it to the same place as my head. Okay, so PTR is equals to head. Let me just write it for you here. PTR is equal to head. Okay, what should I do with my head? I know that this is the target node which is to be deleted. In order to satisfy the property of my doubly linked list, my head should point to the first node, and this node, this highlighted node is going to be deleted. So it is no more going to be my first node. So I need to first of all move my head. Okay, so I'm going to move my head here. Head is equals to head of next. Okay, so what I did, what is head of next? 1010. Okay, so I moved my head here. Now it is pointing to 1010. Fine, this is my head. Okay, now all right, now see what I have to do with PTR. This PTR is still pointing here. Okay, this PTR has not moved. That PTR is still here because it was having the previous value of that head. So PTR is equal to what? 1000. All right, we moved our head to head of next. Fine, now what we have to do, first go and update this value. Okay, so now head of previous is equal to 0 or null, you can say. Okay, fine. So this 1000 which was pointing backwards here, what we are doing, we are deleting this backward link by updating this 1000 to 0, or you can say X. Okay, fine. Now what I have to do, now I have to free up my PTR. So I'm going to call my free function for my dynamic memory allocation, and there I am going to pass my pointer. Okay, so this free PTR is going to give this value 1000. Okay, because it is pointing there. So this whole node, okay, this whole node will get deleted. Okay, this PTR, okay, will now no more point anywhere. It is now, your PTR is now a null pointer, a null value. Okay, so see, now check, my head is pointing to the first node previous is having null value. Okay, rest of the things remain same because we have not done any changes. Okay, so that is my correct form of my delete from the beginning is successfully done. Got it, everyone? Delete from the beginning case.
Yes.
Rest of the others? See, there is an experiment, okay, of your doubly linked list, and we are going to see 4 cases there, 2 insertion and 2 deletions there. So I hope these things are getting clear with all of you. Fine. What is our next case now? Delete from the end. Okay. We know it is standard, the cases. So yeah, for your reference also, there is one diagram in the PPT. All right. So if you are not comfortable with Excel, you can just have a look at this diagram. All right. From the diagram also, you will be able to understand. Go for delete from the end now. All right. Now see, which is our target node? This is my target node. Okay. This is my target node for delete from the end. Okay. So let me just write it for you here. So can anyone say how logically I'm going to delete from the end? Just give your logic. How can I delete this portion? Or tell me what will be the changes if I delete this one? What all changes I need to go for? The
We will
highlighted,
use a while loop.
We need to traverse head till the end.
yes, we are going to need a while loop to traverse. Absolutely right. Then,
Then
Then
we
we
will check while.
no, the traversal is done. The traversal is done. Traversal we will do with 1 pointer, 2 pointer. How many pointers?
One pointer.
Okay, yes, you can do it with 1 pointer also. You can take it 2 pointers also.
Then when the node is reached,
will
then
bring
we'll
head to the
just
last node.
Okay. So you will try to make a pointer point to the last node, right?
Then we will head of next equal to null. Then we'll make and then free up the space.
we will
Head
set
of,
temp. We will set temp of previous of next equal to null as well.
correct. Absolutely right. Vijay, you are right. With the help of 1 pointer, you are going to go for temp of previous. Previous means here, and next part of that. Okay, so you are going to, what you are going to do is, if you want to, sorry, if you want to delete this particular node, okay, so obviously this last second node is going to be what? Your last node after this deletion. And we know that in doubly linked list, the last node should have null value. So this is one of the change which you need to do. Okay. Now in order to do this change, okay, and to delete this particular node, you will need one pointer to point either on both of them or just this one. Okay, if you are going for one pointer, okay, then you should make it sure, make it a point or make sure that that one pointer is at 340. Okay, fine. And if you are taking 2 pointers, then make sure that one pointer is here at the last node and one second pointer is here at the last second node. Correct? So you can do it with both the ways. Both the ways are correct. You can do it with 1 pointer also. You can do it with 2 pointers also. Let's go first for the traversal part here. Okay, how am I going to traverse? See, first of all, again repeat the same steps. PTR equal to start, pre-PTR equal to PTR. We have assumed that start is not equal to null. Okay, but every time when you go and write your delete operations, okay, then you have to, check that if your start is equal to null or not. All right. PTR equal to pre-PTR, okay, and PTR is equal to start. Fine. So here again I'm taking this only. PTR is equals to your head right? And your pre-PTR is equals to PTR. Okay. So all the 3 pointers, head, PTR, pre-PTR at 1010. All right. Now what I need to do? Go for traversal. Now what is the condition for traversal? PTR of next, the next portion is not equal to null. Then move forward. Okay. Why we are considering the next? Because we know that if the next portion is null value, that means we have reached the end. All right, we have reached the end of our doubly linked list. So that is the condition we want to reach here. So what we are going to write here, PTR of next, all right, is not equal to null. So till that time what I need to do, pre-PTR should take position of my PTR and PTR should move forward. Fine. So let's see again. Let's go for the traversal. PTR of next. Where is my PTR? Pointed by your head. Head value is 1000. PTR of next. What is the value? 2012. 2012 not equal to null. Correct. So what I need to do? Pre-PTR equal to PTR. So pre-PTR remains as it is here. Okay. What about my PTR? PTR should move forward. Alright, so PTR is now here.
मैम जो फर्स्ट नोड का नेक्स्ट लिंक है उधर 1015 नहीं आएगा?
हाँ, वो बीच का वो नहीं प्रिंट हुआ होगा
और 2012
हाँ हाँ समझ गई वहां से वो कॉपी किया था ना तो नीचे का नोट नहीं आया होगा इसमें ठीक है ओके नाउ सी नेक्स्ट अगेन PTR of next क्या है 150 okay so 150 not equal to null so what I need to do pre PTR position is equal to my PTR position is equal to my PTR of next is 150 okay 150 बैकवर्ड लिंक में 1015 यहाँ पे भी 150 okay 1020 forward link right done now again check PTR of next what is PTR of next 1020 okay so not equal to null so what I need to do move my pre PTR first then move my PTR done now see we have reached our target area where the changes are going to happen okay now again if you check PTR of next that is null not equal to null so this while loop is going to stop okay now once it is stopped what you need to do see have a look at the algorithm end of loop step number 6 update your pre PTR next okay so update this value what you are going to update it with null okay why null because that is going to be your last node now okay so pre PTR next is equal to null value so what you are doing you broke this link okay by updating this value as x fine or you can say by updating the value as null. Now what you need to do? Now you are going to free. Call your free function and pass ptr value there. Okay, so this free function is going to free up this whole thing, this whole memory block. Okay, now see, check again. Head is pointing to the first node previous is null. Okay, rest of the all the nodes in between are having forward backward link. The last node here, okay, the last node is what? Having null value. So you have successfully done delete after, or say delete end, not after, sorry, delete end. Got it, everybody? Any doubt here? Anyone? See, even if you don't write algorithms in a formal way like this, okay, as they are mentioned in your PPT, then at least make a point that in rough, okay, I'm not saying you make some notes or not. It is better to make some notes in your DS, but okay, in rough also, you can draw these notes, okay, create just by doing arrows, create a backward forward link and try to practice all these cases, okay. Start with delete from the beginning and delete from the end. They are the easiest one. Then you go with delete from the delete before a specified node, okay, and then you go for delete after the specified node. All right, that is what you can do for practice purpose. All right, let's go to the next case now. The next case is of yeah, again here I have placed the diagram for you. Okay, if you are not again comfortable with the Excel, you can just have a look at this diagram. What all things are happening in this diagram is also written very clearly. Okay, so I don't think you'll need much help there. The next case is new node deleted after a given node. Okay, let me add some nodes here. Otherwise, by the time we finish all the cases, there will be no DLL. Are they merged? Okay, I'm now deleting this all. Right. This is Momo X. Let me just change here the address value. Let's say 1000. I hope I'm not given 1000 anywhere. No. So here 1000. Here it will be 150. Here 1500. Here 1500. No. So here 1500. This will be 100 and X. Okay, done. Fine. Now what we are going to do, delete after. Okay, delete after a given node. So tell me what should be the steps if you want to go for delete after. Just logically you tell me. What do you think you should be doing for the very first time? What should be your first step? Delete after a given node. What should be your first step?
To check whether the double DLL exists or not.
Exactly, exactly. Very good, Tushar. You have to check that your doubly linked list is existing or not. It is existing. It is in front of our eyes. Okay, done. Now what?
Now ask the value which after which we want to delete the node.
Exactly. Vijay, what you are writing your while loop is that you need, it is right, but you need to take that value. Okay, so what you are going to do, ask the user after which he or she wants to delete. Okay, let's denote it with num value. Okay, so num is equals to, let's say we are taking 300 or both are 300. Wait, 300, 340. Yeah, I forgot. 360. Okay, let's say after 300, 300 is my num value which I want to delete. Okay, so num is equals to 300. That is what we have taken from the user. Fine. Now the num value is 300. Now do the while loop. Okay, so Vijay, now you are right. While you are taking pointers. Okay, so pointer data. From where you are going to start again? PTR is equals to head, pre-PTR equal to PTR. Alright. So while PTR of data is not equal to your num value, till that time you have to traverse. Okay, so that is what our algorithm is also saying. Pre-PTR of data is not equal to num. Set pre-PTR equal to PTR, PTR equal to PTR of next. Okay. In this case, we are taking pre-PTR. Here, if you are denoting PTR, then you have to write a reverse here, that PTR equal to pre-PTR. Okay. And pre-PTR is equal to pre-PTR of next. Okay, it is your choice which one you want to go forward and which one you want to keep one node behind. Okay, which pointer. All right, but then you have to make changes. Don't go and do like here you are taking PTR. Okay, PTR of data, and then here you are using these two steps, that pre-PTR equal to PTR and PTR equal to PTR of next. Don't do that. Make sure that whichever data you are taking here, in this case, delete after. Pre-PTR of data not equal to num, then pre-PTR, okay, is remaining one node behind your PTR. Fine. So here if you are taking PTR, then PTR should remain one node behind your pre-PTR. Alright. So Let's go for the traversal. PTR of data. PTR pointed by 1010 and the data part is what? 200. 200 less than not sorry, the 200 not equal to 300. True. What I need to do about my PTR? My PTR is equals to pre-PTR, so it is going to remain here only. Okay, so here is my PTR. What about my pre-PTR? It should move to next. Okay, now pre-PTR is pointing here. What is next? 1015. Okay, so here's my pre-PTR. Alright. See, if you go and compare all your delete after the given node, okay, you are going to find the same kind of mechanisms. So if you remember just one case out of all the variants of your linked list, you will be able to solve pretty much all the cases of deletion for all the given variants. Okay, it is not like so many delete here, delete there. Again, if again linked list changes, then delete here, delete there. No, it is not like that. If you go and compare, only singly linked list and circular linked list will have some, difference. Otherwise, rest of the things remains same. Okay. Is my voice audible along with my video?
Yes, ma'am.
Okay, because my other device is showing some errors. That's why I wanted to clarify. Okay. See, by any chances, if you are not hearing my voice clearly or the video is not available, please tell me then and then only. Okay. Alright, now let's go for next iteration. Next iteration is what? Again, PTR of data. What is PTR of data? 200. 200 not equal to 300. What I need to do? Move my PTR and pre-PTR. PTR moves to the place where pre-PTR was. Pre-PTR moves to the next node. Again check. PTR of data 240. 240 not equal to 300. Move my PTR pre-PTR. So X and V, again X and V. Now again 300. 300 is not equal to my num value, which is 300. So that is false, right? So you can make out that we have reached the target area. Why this is our target area? Because after 300 we want node deletion to happen. So after 300, which is the node, this one. Okay, so this node is to be deleted. Now in order to delete this node, okay, if I go and delete this node, obviously I have to update PTR of next, okay, and this part, correct? Now I have not reached here, but still I am going to update this part. See, no, there is no pointer here who is pointing to this last node, but still I will be able to, update this part. Let's see how. First of all, go and update this PTR. Okay. So what you are going to write? Finish up the easy portion first. Okay. So PTR of next is equal to, now this, instead of this 1000, it should point to 1500, right? Now this 1500 is the value stored in pre-PTR of next. So it is easy to give here. So PTR of next is what? Your pre-PTR of next. Okay, so what you are doing? You are breaking this link. Okay, this link is getting broken by updating this value from 1000 to 1500. Okay, so what you are doing now, this link is getting pointed here. Okay, this link is now pointing where? here. Okay, you broke the link. Now we have to update this also so that it is pointing to this node. Okay, we need to break this link. Now how can you reach here? If you want to go and update this value, how can you reach here? See, then there is one method here. Pre-PTR of next of previous is equal to your PTR. Now see how the control is going to work. It is going to first identify what is pre-PTR of next. What is pre-PTR of next? 1500. Okay, so it is going to go to 1500. Then what is the value? Pre-PTR next of previous. Okay, so pre-PTR of next it reached, of previous, that means this value. It has to be updated with what? The value of my PTR. Okay, so I reached here. It updated with 150. Fine. So basically what we did, we broke this link. And now where it is pointing? It is pointing here to my 150. Okay, this is what things are happening. So you created one forward link, you created one backward link. Now you can easily, without any tension, you can free up this whole memory space from in between. Okay, so what you are going to do? You are going to call your free function. So free function, inside that, what will be the pointer? Your free PTR. Alright. So what this free function is going to do? It is going to delete this whole node from your memory. Okay. Now check. There is a head who is pointing to the first node previous X. All the rest of the nodes are having forward and backward link. Okay, and the last node is having null value. So your delete after a given node is successful. Any doubts here? Yes or no, students? Any doubt? Any in any case till so far? See, I have got students who are inquiring me again that they can understand the theory, okay, but when practical part comes, they're facing difficulties. Now in order to remove those difficulties, you have to think in a manner as we are doing the working right now with your Excel. Okay, identify which is the node getting deleted. Identify then what will be the changes occurring if I delete that node. And in order to identify these two things, you have to create a rough image of whichever variant of your linked list you are working on. Okay, you have to draw these nodes, identify your target node either for deletion or insertion, no matter what. Okay, identify your target node, then go and see which are the links which will require the changes, whether you have to give some new values to those nodes, or you have to go and update those values. Identify those, okay, and then go for traversal and then go and update or create those links. Okay, this is the step. Draw the logical structure of the variant of the linked list that you are dealing with. Okay, keep in mind the case. Suppose it is delete after the given node. Then find out first of all that which is the number after which you want to delete. Okay, once you finalize that number, all right, then identify which will be the target area, right? After you finish identifying that, then go and have a look that what are the changes needed to be made. Okay, what are the links that are to be broken or that are to be updated. Fine, and then go and decide how you are going to reach to that target node. So it is easy. If it is before or after, you have to compare the data. Okay, is it equal to your given supplied input or not? Okay, and if it is in sorted, then you have to see that it is less than or not than your given node. Okay, so this is the way, and it is the easiest way. Once you do like this, you will find a linked list very easy. Okay, fine. We can go with one more case. Okay, that is node is deleted before the given node. See here in this algorithm, what I have done is I have taken one more way. I told you that no logic will remain the same, end result is going to remain the same. Programming techniques can differ. So here there is one temporary pointer taken, okay, who is storing the value of your PTR next. Fine, and we are moving it with the temp of previous. Okay, you don't need to do this. If the steps are getting over with just 2 steps, then you don't need to go for 3-step method. All right, that's why I told you that I'm going to supply, I'm going to give you this Excel file also in your e-contact, and that's why I'm writing all these small steps. Okay, because later on it should not happen that you are seeing this particular PPT, you are finding something different than what we have discussed. Okay, and with respect to the things which are different, okay, I have provided you the diagrams. All right, so with the help of those diagrams, you can easily understand the given previous algorithm. All right, even if you don't get the Excel or due to one or the other reason you are not able to access the Excel file, then the diagrams are already provided in your PPT. Right? Moving on, new node deleted before a given node. Again, follow the same steps. Okay, go and check your DLL is existing or not. If it is existing, then take 2 pointers, both of them pointing to the starting position, that is start. Okay. Again, same traversal. PTR of data not equal to num. Okay. PTR of data not equal to num. Again, the same thing here. But what is the change this time? The change is, suppose 300 is the numerical value. Okay. So obviously this one is going to be what? My target node to be deleted. Okay, just let me write here. Delete before a given node. Okay, again ask the user before which node he or she wants to delete. Okay, so before which node delete is to be done. Let's say again the num value given as 300. So this is my target node. Now if I delete this one, what all changes will be needed? This node next will need a change. It has to update its value to 150, and this 150 previous part need changes. Correct? It should 0.21010, right? Because we are going to remove this one. So now again, while PTR of data not equal to num, okay? So PTR of data, what is PTR of data? Here 200 not equal to num, okay? So 200 not equal to 300, yes. So what I need to do with my PTR? PTR remains here, free PTR here. Fine. Again check PTR of data. Again check here. PTR of data. Okay, what is PTR of data? 240. Okay, so 240 not equal to 300. Alright, so what I need to do? PTR will be here. Okay, pre PTR moves here. Next. Wait, I messed up. Wait. PTR of data, that is 200. 200 not equal to 300. Okay, so what I do? PTR remains here as it is. Okay, your pre PTR moves forward. Okay, again PTR. So again 200 not equal to 300. Okay, so your PTR will move forward along with your pre PTR. Okay, so move my PTR. Do you guys think we are going to face any difficulty? Two 40 less than or equal to 300. What I need to do? Again, move. My pre-PTR moves to next here. Okay, and my PTR is going to move here. 300 not equal to 300. So my while loop stops. Okay. Now you tell me guys, am I going to face any difficulty here? The diagram is in front of you. PTR is here, pre-PTR is here. Now you tell me, am I going to face any difficulty?
Yes.
What is that?
We won't be able to free the node which we want to delete because there is nothing is pointing towards it.
No, I can do that with the help of PTR next. PTR previous. I can do that. This node can be deleted. Node deletion में problem नहीं होगी. Problem कहाँ
We
होगी?
cannot link नहीं कर पाएगा क्योंकि वो दोनों पॉइंटर उस तरफ है. उधर पॉइंटर जिधर हम लोग करना है.
Exactly. तो इसके लिए हमें क्या करना होगा?
एक और पॉइंटर ले लो. Last option.
एक और पॉइंटर लेंगे तो थोड़ा टाइम कॉम्प्लेक्सिटी वगैरह में इश्यूज नहीं आएंगे. थर्ड पॉइंटर अगर हम ले रहे हैं तो चलो मैं कंस्ट्रेंट डालती हूँ. सही है, ऐसा नहीं है कि आप नहीं ले सकते. यू कैन टेक थर्ड पॉइंटर, बट आई एम कीपिंग अ कंस्ट्रेंट. आई वांट टू वर्क विद जस्ट 2 पॉइंटर्स. देन
अपडेट करना पड़ेगा while loop के बाद में जो स्टेटमेंट है.
ओके, कैसे अपडेट करेंगे? करेक्ट जा रहे हो? क्या अपडेट करेंगे उसमें? We will inverse this statement first. जो हमने यहाँ पे ऐसे लिखा है ना, PTR is equals to pre PTR. We will inverse that statement. Pre-PTR is equals to wherever the position of PTR. So what we did, we are making this pre-PTR one node behind my PTR. अगर हमने वन नोड बिहाइंड कर दिया इस pre-PTR को, तो ये वैल्यू हम अपडेट कर पाएंगे फॉरवर्ड लिंक के लिए. PTR तो है ही हमारे पास बैकवर्ड लिंक को अपडेट करने के लिए, और pre-PTR की हेल्प से हम ये पूरा बीच का नोड डिलीट कर सकते हैं. Did you guys get it? पता चला क्या हो रहा
Yes.
है कि नहीं पता चला?
Got it.
हम लोग सिर्फ दो चेंज करेंगे यहाँ पे, सिर्फ दो चेंज. क्या करेंगे कि आफ्टर में हम लोग क्या कर रहे थे, पीटीआर को प्री पीटीआर की पोजीशन दे रहे थे, ठीक है, ताकि पीटीआर हमारा पीछे रहे. बिफोर में हम लोग क्या करेंगे, उसी चीज को इनवर्स कर देंगे. वी आर गोइंग टू रिवर्स दैट थिंग so that pre-PTR remains one node behind my PTR and PTR should move forward. Okay? तो देखो रिवर्स हो गया. यहाँ पे देखो while में क्या कर रहे थे, PTR is equals to pre-PTR, pre-PTR should move forward. यहाँ पे हमने क्या किया, रिवर्स कर दिया. Pre-PTR equal to PTR and PTR is equal to PTR of next. Okay? क्यों किया ये रिवर्स? So that we can access this portion, क्योंकि ये पोर्शन हमें डिलीट अपडेट करना पड़ेगा. ओके, हमें ये नोड को डिलीट करना है तो उसके लिए पॉइंटर चाहिए होगा जो उसको पॉइंट करे. ओके, एंड एक पॉइंटर ये भी चाहिए कि जो इस चीज को, इस 1015 को अपडेट कर पाए. ओके, सो लेट्स गो एंड अपडेट दिस बैकवर्ड लिंक फर्स्ट. सो पीटीआर ऑफ प्रीवियस, ओके, पीटीआर ऑफ previous is equal to what? Is equal to pre-PTR of previous. Okay? क्यों pre-PTR of previous? Pre-PTR of previous क्या है? 1010. तो ये यही तो हमें नोट चाहिए, राइट, बैकवर्ड लिंक के लिए. तो हम यहाँ पे क्या करेंगे, 1010 हमने जैसे ही अपडेट किया, you are breaking this backward link. Okay? And you are going and creating a new backward link, something like this. ऐसे किया आपने, ठीक है. अब नेक्स्ट क्या करोगे, नेक्स्ट ये तो लिंक अपडेट हो गई. अब इस लिंक को भी तो अपडेट करना है ना मुझे. 150 को भी मुझे यहाँ पे प्लेस करवाना है. वो कैसे हो सकता है, प्री पीटीआर नेक्स्ट की बदौलत. या तो डायरेक्टली पीटीआर की वैल्यू दे दो, ठीक है. दो तरीके से हो सकता है कि या तो प्री पीटीआर नेक्स्ट की वैल्यू दे दो तो वो भी 150 है, पीटीआर की वैल्यू दे दो तो भी 150 है. लेकिन इस चीज को, इस एरिया को कैसे एक्सेस करोगे, हाउ यू आर गोइंग टू एक्सेस दिस, विद द हेल्प ऑफ प्री पीटीआर प्रीवियस ऑफ नेक्स्ट. तो यहाँ पे क्या लिखोगे, प्री पीटीआर previous of next is equal to PTR. Pre-PTR previous क्या है, 1010. तो कंट्रोल यहाँ पे जाएगा इस नोड के पास, उसका नेक्स्ट तो ये पार्ट प्री पीटीआर प्रीवियस, तो मतलब कंट्रोल गया 1000 पे, और उसका नेक्स्ट मतलब ये पार्ट, ठीक है. तो यहाँ पे जाके आपने 150 वैल्यू दे दी पीटीआर की. तो क्या किया, ये फॉरवर्ड लिंक जो थी इन दोनों के बीच में वो आपने ब्रेक कर दी. ओके, और ये लिंक क्रिएट हो गई. ठीक है, ये एक लिंक क्रिएट हो गई. तो अब आप आराम से इस बीच वाले नोड को डिलीट कर सकते हो. ठीक है, ये डिलीट करोगे तो ऑब्वियस है कि ये दोनों लिंक्स भी टूट जाएगी उसके साथ ही, क्योंकि उसके दोनों मेंबर्स डिलीट हो रहे, फ्री हो रहे. सो गो एंड फ्री अप योर प्री पीटीआर. वंस यू फ्री अप दिस प्री पीटीआर, ओके, then your diagram will look something like this. ये हमने फ्री कर दिया यहाँ पे, तो देखो डिलीट वाली पहले वाली डिलीट हो गई। अभी चेक करो डब्ल्यू लिंक लिस्ट एग्जिस्टिंग है या नहीं है। हेड पॉइंट कर रहा है, प्रीवियस लिंक नल, फॉरवर्ड बैकवर्ड भी सही है, ओके, और लास्ट लिंक अगेन नल। गॉट इट? क्या करना है, वंस अगेन डिलीट बिफोर, सो आस्क द यूजर कि कौन से नंबर से पहले डिलीट करवाना है, ठीक है। पीटीआर ऑफ डेटा को कंपेयर करवाओ, और ट्रावर्सल कैसे करना है कि प्री पीटीआर एक नोड पीछे रहे पीटीआर के, ओके। सो गिव द वैल्यू ऑफ पीटीआर टू योर प्री पीटीआर, ओके, एंड पीटीआर इज इक्वल्स टू पीटीआर ऑफ नेक्स्ट, ठीक है, ताकि प्री पीटीआर एक नोड पीछे रहेगा पीटीआर के। अभी टारगेट नोड टारगेट एरिया पे पहुंच गए तुम लोग, ठीक है, तो अभी जाकर लिंक को अपडेट करो सारी। सो पीटीआर ऑफ प्रीवियस, तो इस लिंक को हमने अपडेट किया विद द हेल्प ऑफ प्री पीटीआर प्रीवियस, ओके। और इस वाली लिंक को हमने कैसे अपडेट किया, तो कि हमने कंट्रोल को बोला कि प्री पीटीआर ऑफ प्रीवियस पे जाओ, तो कंट्रोल गया प्री पीटीआर ऑफ प्रीवियस पे, मतलब ये नोड पे, और उसका नेक्स्ट पार्ट, तो उसका नेक्स्ट पार्ट हियर वो एक्सेस हो गया, ओके। वहां पे जाके हमने पीटीआर की वैल्यू दे दी, ऑलराइट, सो इट इज 150, और बाद में जाके हमने पूरा नोड बीच में से फ्री कर दिया। सो दैट इज योर डिलीट बिफोर द गिवन नोड। डाउट anyone here, any confusions? Are you guys getting it or not? देखो आई नो बहुत सारे केसेस हो गए हैं, ओके, बहुत सारे डिलीशन है, बहुत सारे इंसर्शन है, ओके, बट इफ यू अरेंज in your you know in your brain memory in your brain memory, if you are arranging in stack wise, okay, कि ये स्टैक हो गया मेरा पूरा लिंक लिस्ट का इंसर्शन डिलीशन, ये हो गया स्टैक पूरा मेरा डब्ल्यू लिंक लिस्ट का इंसर्शन डिलीशन, ये हो गया मेरा सर्कुलर लिंक लिस्ट का, ओके, तो इट विल बी इजियर फॉर यू, राइट। Again, see, here I have taken one temporary pointer, okay, so यहाँ पे मैंने 3 पॉइंटर से काम किया है एल्गोरिथम में, ओके, तो ऐसा नहीं है कि आप नहीं कर सकते, you can do it, but you can do it with this way also, using just 2 pointers, you can do it with 1 pointer also, okay. It is not that in this case, in particularly in W linked list, you can work with 1 pointer also, okay, you can work with 2 pointers also, and you can work with 3 pointers also, the choice is yours, end result same ही होता है सबका, ठीक है। We will continue in our next session with your new kind of a variant, that is circular W linked list, and do not worry, this is the last one, okay, circular W linked list, this is the last one, all right. We are going to continue that in your next session, okay. We are going to keep this session till here, and now what we are going to do, we are going to try to revise your linked list from the very beginning, okay. But what is your job in that? I need answers from at least 80% of the strength in this meeting, okay. I don't just want Tushar or Vidhi or Shri, Raj, Darshan only answering, Yasin answering, okay. I want Preet to answer, I want Girish to answer, I want Bhavdeep or Harshvardhan to answer also, okay. And these are some of the students I remember, okay. It is, I want everybody to answer, it will be really nice, but you know, I don't want a few of them, a handful of students who are answering, okay, because I know they are getting things, but I want each and every one of you to at least try. Okay. I'll save this for you guys. Okay. Now see, in this picker wheel, I hope this picker wheel is seen to you. Is it visible?
Yes, ma'am.
Okay. See, here I'm going to spin the wheel. Okay, this spinning the wheel is nothing new to you guys. Okay, in nowadays those festive seasons and online sales have been there, so there are these kinds of spinning wheels. What change I have made here is when I go and spin the wheel, okay, it is going to stop at one of the topic. All right, at one of the topic, it is going to stop. Whoever knows the answer, okay, you can either write in the chat or speak, okay, one by one. Don't go and speak all the points, okay, just speak one point which you know, and other students, if that point is already spoken, then you have to think for other points. For example, if I'm saying here singly linked list, okay, then if one student is saying that it is a list of homogeneous data, then you are not going to repeat that because that is already covered. Fine, like that I want you guys to answer, but also we don't want to create a havoc by everybody speaking at a time. So just do excuse me, okay, and then you can speak. All right, fine, let's start. Let's see how this goes. Right, it will make this kind of noise, okay, just for the sake of fun. Okay, what we got: doubly linked list properties. Okay, so doubly linked list properties, how you are going to identify that it is your doubly linked list? Come on,
It
tell
has
me.
2 pointers.
Correct. It has 2 pointers, right? Anyone else? Vijay, now you don't say. Now some other student. We are talking about doubly linked list. Now what? It has 2 pointers, exactly. Now previous link of the first node and next link of the last node is null. Correct. Then it can be traversed on both the sides. Absolutely right. Then anything else in your doubly linked list properties? Link to another list, yes. Quickly inserting the new node before the given node, absolutely right. You are missing one main but a very small part. Nobody has mentioned it yet, which is true for every given linked list. And it is very small part, very tiny, minute detail. Yes, of course, delete operation is efficient, correct? But still, students, you are missing one minute detail. One minute detail. Link first and last, yes. A start is null, and at the end, Devansh, at the end it is not null, but the last node next pointer is null. Yes, guys, but still a small, very minute detail you are missing out. It stores non-contiguous data. Yeah. Delete operation more efficient. Yeah, covered, Aditya. See, I'm giving you the hint. Listen to my hint again. That minute detail which I'm talking about, the answer which I want from you guys about that minute detail, it is true for every given linked list variant. Resizable, Okay, but that is not what I am searching. The answer from you guys. Still think. Exactly. Correct, Yasin. The head pointer is always going to be the pointing towards your first node. Okay, that is also one of the property, and it is true for every given linked list. In your single linked list also, the head pointer is, pointing to the first node. In your circular doubly linked list or circular linked list, the head pointer is always going to point to the first memory address of your first node. Okay, so clear. I can see each and every one of you are answering really good. Okay, let's go for the next topic now. Hide the choice. Circular linked list. Okay, what can you say about circular linked list? See, this is
We can
circular linked
traverse
list.
from
Okay?
one end to the other end.
Tushar, please repeat.
We can traverse from one end to the other end.
Correct. Anybody else? Last node has address of the first node. Absolutely right. Last pointer and first pointer are connected. Yes, right. Anything else? First element points to the last element. First element points to the last element. No, Nidhi. Last element points to the first element. That is right. The first element does not point to the last element. No, Tushar, not that also. See, insertion cases, yes. Circular linked list. This diagram should come into your picture, okay, in your mind. This picture should come because it is circular linked list. The first node, okay, is pointing to the next node. The last node only will point back to your head node, okay. It is not vice versa. Head node does not point back. Okay, only the last node will point to your head node. Okay, remember this. Okay, Harshvardhan says singly and doubly can be made into a circular linked list. That is the variant. That is not the discussion that can come into your circular linked list. That is the variant, Harshvardhan. Reversing is complex. Yes, very good, Deep. Doing great. Reversing is complex because why? You have to traverse. If you are in between somewhere here at node 2000, okay, and you want to go and update this particular node for any kind of an operation, you compulsorily have to go to the last node, go to your head node again, and then come back here. Okay. So right, reversing is complex. Again, you can mention here, head is always going to point to the first node, okay, and the last node is going to have the memory address of your first node. Rest all the nodes are connected in single manner, okay, no backward links in between nodes. That is the property. Okay, there is no backward links for the nodes which are in between your first and the last node. Okay, so see, that's why I told you that you keep this diagram in mind. You focus circular linked list. Okay, if it is circular linked list, that means a singly linked list, okay, whose last and the first node are connected. Alright, but don't make a mistake that even the first node is going to point to your last node. No. Fine. Correct, Harshvardhan. Proper care is not taken, then there can be an infinite loop also while programming this. Okay, so good. Everyone remembers, everyone has, see, from this what you are going to make out for yourself, that you at least have a clarity on the concept. Now the only thing which you guys have to work on is what your algorithms, I suppose, are also clear. Only thing which you need to work on is with your programming. Okay. And in programming, just like your mathematics, you are going to need practice. If you practice these small, you just practice just one algorithm at one time. Okay. Don't go for all the deletion. Don't go for all the insertion. Do programming. Do a small program. Create your linked list and do just one algorithm in that. Okay. It will be helpful. Okay. Next topic. Advantages of your linked list. What are the advantages? You can speak, no problem. Dynamic memory, correct. Due to dynamic memory, what are the advantages of using linked list? Dynamic memory is a generalization. No wastage of memory, yes, right? What about that, Dev? About insertion and deletion, what about that?
We can insert and delete at any place.
Correct. Absolutely right. You don't need to go and resize unlike your arrays. Items can be added and removed in the middle of the list. Yeah, absolutely right. Stacks and queues can be easily implemented. Correct. Anything else? With respect to dynamic memory? Yes, Harshvardhan, that is covered. That is covered. That topic, that point got covered. What about Darshan? If Nikita is there, all the two Nikitas, Kaf, Aditya, you guys do not remember or facing some difficulties in remembering. Priyank is also not answering. Correct, Yasin. Efficient memory utilization, absolutely right. No need to define the initial size. Very good, Harshvardhan, right? You are not going to define the initial size unlike your arrays. Anything else remaining? Exactly. Reverse traversing can also be done. Bullseye. Good. Let's go for the next spin. The easiest one, singly linked list. Come on, quickly. What can you say about singly linked list?
Traversing can be done from one
No.
side, from beginning only. Beginning or the end.
Correct. Right. Then, what can you say about the links? Head pointer points to the first address. Absolutely right. What can you say about the links? Only one pointer. Yes. Right, Vidhi. What about the links? Poor memory utilization. Every member includes an address size member. You cannot say poor memory utilization. First pointer and the last pointer are null. No, Raj. We are talking about singly linked list, guys.
Only last pointer is a null.
Correct. See your SLL insertions. Only the last pointer is going to be null. Okay. Linear collection of data. Very good, Smith. What I'm saying is, with the, what can you say about the links? They are traversing in forward direction only, or it can go in one directional only. It is not bidirectional, like your DLLs. Okay, your SLL is single directional. It is not bidirectional. Okay, head pointer points to the first node, last node, next pointer is null. Okay, so that is your singly linked list. We can go for one last spin. What is the condition for Q to be empty? This is Q. Okay, this is not linked list. Come out of the linked list. Go to the topic of Q now.
Front and rear should be
Rear
minus
and
1.
top go to null.
Front and rear is equal to
Minus 1.
exactly. Condition for Q. If it is Q, you have to keep in mind that there are two variables. Okay, because it is Q. The front of the Q and the rear of the Q. Okay, and condition for the Q to be empty is both are pointing to the null value. Front and rear equal to -1. Okay. There are what is remaining condition for stack and linked list empty condition. Okay, we can go for it. Okay. For any linked list to be empty, see, I have just said linked list. Okay, so it can be a singly linked list. Ideally, it is just a singly linked list, but this is what I am adding right now. For any linked list to be empty, what is the condition? Exactly, your head is equals to null value. When your head is pointing to any null value, okay, then you can say that your linked list is empty. Okay, and you have to keep this in mind while going for your delete operations. Okay, and the only thing remaining, condition for stack being full.
Top is equal to stack size -1.
Exactly. Top is equals to no. Oh yes. Oh yes, yes. Sorry, my mistake. Condition for stack being full. Stack size -1. Okay. Stack is having what? A variable called top. Okay. If this is your stack, okay. So stack is going to have a top variable. Top is going to have the position here. Okay, so if it is stack size -1, then you can say that your stack, your entire stack is full. Okay, fine. So this was your revision for linked list, some variants, a little bit of stack and a little bit of queues. Okay, we are going to end our session here. I hope you liked the revision which we done in a way. You liked this? You liked this way of revising the spinning wheel? Okay. Maybe in the next session I'll come up with one new way. All right. So that the session does not, it is not just me giving you the knowledge and you retrieving it. Okay. It is both the ways. And this way, even you don't have to go again and see the video. You can just remember via these visuals. Alright, so we are going to keep this session till here. Thank you all for attending the session. BD students, write your numbers in the chat. Serial order manner.
Hello, ma'am. Hello, ma'am.
Yes,
Hello, ma'am.
yes, I can hear you.
मैम मेरा नेट बहुत ज्यादा फ्लक्चुएट कर रहा है मैम. टाइप करूंगा तो भी मैम चला जा रहा है नेट. तो मैम आप लिख लोगे मेरा रोल नंबर?
क्या नंबर है आपका?
मैम AI34.
ओके, ठीक है.
थैंक यू.
BD students after 5, 6, 7, 8, 9, 10, 11. Nobody? Yasin, your number is not there? Okay. Fine. AI students 1 to 10.
Ma'am,
11 to
6.
20. Okay. 11 to 20. 21 to 30. 31 to 40. 41 to 50. 51 to 60. 61 to 75.